So today we will be learning about discrete random variables and its probability distribution. What does it mean when we say discrete random variable? What discrete?
Like
That it can have only certain values. For example,
quantized states.
Yes, quantized states. So if you toss coin 3 times, what can be a discrete random variable?
heads and tails.
Not head and tails.
How many heads
There
and
will be,
tails?
let's say, how many times we
head
will
and tails
get
is tossed.
head. You
Yeah.
toss 3 times, and what the possible values of the random variable? How many times we toss coin 3 times? How many times we can get heads?
0, 1, 2, 3.
We can get 0, 1, 2, 3, and so we can find probability distribution that x equals x. And you, by now, you should be, without drawing tree diagram, you should be able to tell me what will be the probability distribution.
I think it's an 8, 3, 8, 3, 8, and 8.
It's 1, 8,
Yeah.
3, 8, 3, 8,
Yes.
and 1, 8. Important thing that all those probabilities must add up to 1, because total probability, so sum of all probabilities x equals x has to be 1. And that used often in the equation, what we will see later on, when there are some of them might be unknown, and we can find them using this method. Mean, or expected value. How we find the mean or expected value for random
X times probability of X. X times probability of X.
and add. We
add
make a sum of the probability that x equals x times x. And so we, in this case, we 0 times 1, 8, plus 1 times 3, 8, plus 2 times 3, 8, plus 3 times 1, 8, and that will give us the expected value. Also, we need to be able to find the variance of x. Remember how we find the variance of x?
X squared minus.
We find an expected value of x squared. So we square each value of x and find its expected value minus
The square of the X.
expected value of x squared. No, and standard deviation
Is the square root.
equals square root of variance. So it's nothing new for you, you've already learned it. So let's consider few examples which are from the past methods exams. So they might be useful in your preparation for that method. So first example is from 2017.
That would be the
2017 NHT exam 1. NHT exam 1, question 5. Question 5. So there is records of the arrival times of trains at the busy station have been kept for a long period. The random variable x represents number of minutes after the scheduled time that the train arrives. So lateness of the train. Assume that the lateness of the train arriving at this station is independent from the lateness of any other train. So, and this is the distribution of this random variable.
Is it given?
X is minus 1, 0, 1. So it's a difference in time when the train arrived compared to its scheduled time. So it can be minus 1, it means it came 1 minute before, 0 came on time.
What page is it specifically?
It's not.
It's not in the
Oh,
booklet.
okay.
It's not in the booklet. That's why I'll just look through the methods exam and choose a few questions. I thought that it will be useful for you at this stage. And probability that x equals x is 0.1, 0.4, 0.3, and unknown p.
Here.
No, question. Question A, find the value of P.
0.2.
This is like baby question. We need to add them all to 1. So we have 0.8 plus P equals 1. Obviously P equals 0.2. B again, but B pretty easy. Find the expected value.
Yes.
To find the expected value, we need multiply minus 1 times 0.1 minus 1 times 0.1 plus, I will not be writing 0 times this is 0 plus 1 times 0.3 plus 2 times 0.2, and that's equal 0.6. So very easy start. And again, find variance. Still very easy. Continuous question. Again, we just need to find expected value of x squared. To do that, we square our values of x. We get 1, 0, 1, 2. That is x, 4. Well done. No, when it's good like pattern, you continue the pattern. So expected value of x squared during the same time, 1 times 0.
1.2.
That will be equal, expected will be 1.2. And then we will have that variance x, we subtract, we do 1.2 minus 0.6 squared equal 0.84. So that's very easy, nice as a piece of cake, 4 marks in no time in your pocket.
That is really easy.
That is very, very, very easy. Now, another example, which is a little bit hard. So we start from very easy, straightforward example, just based on the definition. So you see, you can get on the final exam, you might have final exam questions like that. I just what I cannot understand that not 100% people get it. Now this is 2019, 2019 NHT exam 2, multiple choice, question 5. Consider probability distribution for discrete random variables shown in the table below. X minus 1, 0, 1, 2, 3. Probability of x equals x is b, 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 3/5 minus b, and 3b on 5. And question is, find the value of e of x, expected value.
You just have them all out.
First step, we find in b, adding all these should be equals to 1. So if we add all that, we will get 30, we will get
Do you result the cats?
no, we will get and equalize to 1, we will get b equal 2 over 13. If you just add all of them. So, now, then we will, when we found b, we just replace it here and we calculate expected value by multiplying those things and adding them up. So just need to do a little bit of fraction work, but calculator is available, so it's no problem at all. And if you do it correctly, it is 76 on 65. So again, but just require a little bit of work of time, but very straightforward. Next question.
How many got right?
Only 15% was right. Next question. This is a difficult question, and that's an interesting question.
Was it from NHT?
Huh?
Is it NH2?
No, this one, if it's NHT, I will not know the percentage because there is no statistics on NHT because it's too small cohort between NHT exams. So this is 2016, exam 2, multiple choice, question 19.
Oh, last one.
Not last.
Nearly.
Last 20.
Yeah.
So we have consider the discrete probability distribution shown x minus 1, 0, b, 2b, 4, and probability x equals x is a, b, b, 2b, and 0.2. And the question is, find the smallest and largest possible values of expected value. Find the largest and smallest possible values of the mean.
Can you give us a second? I want to try it out.
Okay?
Yeah, can you try it?
Yeah? Try any. This is not easy question, that's why only 15% got it right.
There.
And maybe some percentage of them just guessed.
0. Is A allowed to equal 0? Is A allowed?
Yeah, there are restrictions.
What will be the restrictions? That A and B, they cannot be less than 0 and they cannot be more than 1.
Running the minimum or the maximum?
Huh?
The minimum or the maximum?
No, we will need to find both minimum value of E of x and maximum value of E of x.
It's the maximum one.
Yeah? The biggest E of x can be is 1.
And the minimum is 0.
Hmm?
0.
Good, well done, correct. So it will be smallest will be 0, the biggest will be 1. Let's see how we can achieve it. First, using the fact that all probabilities had add up to 1, so we have A plus 4B plus 0.2 equals 1. So we will have that A equal 0.8 minus 4B. We find the relation between A and B from the fact that all probabilities has to add up to 1. Then let's find what will be the expected value. So we have expected value is minus A, 0 plus B squared, plus 4B squared, plus 0.8. Now, we can substitute there instead of A, 0.8 minus 4B. And we will get that will be equal 5B squared plus 4B. Instead of A, we substituting this. We will get negative 0.8, 0.8 cancels out, and we get positive 4B. So that is what expected value is. Now, let's consider what this quadratics looks like. Good idea to look on the graph. So if we factorize it, we get B times 5B plus 4. So it will be x-intercept will be negative 4/5 and 0. But B, we know that it cannot be negative. So looking onto this. So we have the smallest value if b equals 0. If b equals 0, we have a is because we have that a has to be between 0 and 1, and b has to be between 0 and 1. So b can be 0, a is 0.8, so it's in it. So if b equals 0, we get expected value of x equal 0. Now, what the biggest from here, what the biggest the b can be?
22.
Here. Because we have a, the biggest, the smaller the a can be is 0. So we have 0.8 minus 4b means b equals 0.2. The biggest value the b can be, not making a negative. So we substitute b equals 0.2, and we get expected. So when b equals 0.2, expected value equals 1. So this is the smallest value of the expected value. This is the biggest value of the expected value. Any questions? Make sense? Okay, that's all new things relatively. Yeah,
How do
question?
you know automatically that this, when A is smallest, B is largest, vice versa?
A and B positive numbers. So the bigger is B, the smaller will be A. Because B is positive. A and B between 0 and 1 because they are probabilities. Okay. Like, subscribe, and donate to help fight terrorist countries and organizations like Russia, Iran, Hezbollah, Hamas, etc. Support Ukraine and Israel.